Hello, welcome to Madam YY channel. Today we are going to discuss Chapter 4, Aromatic Compounds. So the learning objective for today will be 4.2, Benzene Derivative. So at the end of the session, you should be able to draw and name the benzene derivative, based on the IUPAC Nomenclature for the monosubstituted benzene, disubstituted benzene, and also trisubstituted benzene. And we will also draw and give the example of the benzene when they appear as a substituent, which we will name them as phenyl or benzyl. Monosubstituted benzene means that it has only one substituent. So we will name the substituent and add the word benzene, which will be the parent name. So for example, Br. So it will be, so Br is attached, the carbon Br attached will be considered as carbon 1. So it will be bromobenzene. So we don't have to put 1 in front of the bromo because there's only one substituent. And then the NO2, it will be named as nitrobenzene. And CH2, CH3 is our ethyl. So it is ethyl benzene. So remember, when there's only one substituent, we don't have to add the numbering 1 because the carbon attached to the substituent is always labeled as carbon 1. So that's not necessary to put a 1 in the IUPAC nomenclature. And sometimes the structure of the benzene can also be drawn as a circular structure with the ring in the hexagon shape. IUPAC rules allow some common names of the benzene to be retained. So there are 6 benzene with common name which you need to memorize. So when you have the methyl group as a substituent, the common name is called toluene. Hydroxyl group as a substituent is called phenol. And then amine, the common name is called aniline. Carboxyl group, it will be benzoic acid. And when you have your aldehyde, your carbonyl group attached to the benzene, it will be known as benzaldehyde. And the ketone attached to the benzene, it will be known as acetophenone. So normally we will use the common name instead of the IUPAC name. So next one, disubstituted benzene is when they have, so when the two substituents are the same, so we can use a prefixes such as auto, meta, and para, to identify the position of the substituents. So you can use a prefixes, or we can also use the number. So auto, O is telling us the substituents is at the carbon 1 and 2, and M, the substituent is at position 1 and 3, and P, the substituent is at the position 1 and 4. So you can use O to present the position or the number. So now let's look at this example. We have 2 bromine attached to the benzene ring. So the position is at carbon number 1 and 2. So the IUPAC name can be 1,2-dibromobenzene, or we can also use O-dibromobenzene. So when the position is at carbon 1 and 3, it will be 1,3-dibromobenzene or M-dibromobenzene. So the position when it is attached to carbon 1 and 4 can be known as 1,4-dibromobenzene or P-dibromobenzene. Okay, so let's look at another example, which we have a two methyl group attached to position 1 and 4. So it can be 1,4-dimethylbenzene or p-dimethylbenzene. And this one is two nitro group attached to carbon 1 and 3. So it can be m-dinitrobenzene or 1,4-dinitrobenzene. So two hydroxyl group attached to position 1 and 2. So this one is named as 1,2-benzene diol. And when we have two, okay, 1,2-benzene diol. And when we have two carboxyl group attached to the benzene, it's called benzene 1,4-dicarboxylic acid. So for these two structures, I think it's easier for us to use a number instead of the prefixes. So how about when the two substituents attached to the benzene ring are different? So we need to alphabetize the name of the substituent preceding the word benzene. So it means that benzene will be your parent, and we have to follow the alphabetical order of the substituent. So for example, here I have a chlorine and bromine, okay, attached to my benzene ring. So which of the substituent, okay, we should give the number 1, okay, we should label as carbon 1, okay, which of the substituent. So we need to follow the alphabetical order, which is B first, and after, okay, so B comes first. So the carbon attached with the bromine will be labeled as carbon 1. So it will be 1, 2. So or bromo-chlorobenzene. Or we can also known as 1-bromo-2-chlorobenzene. So bromo, okay, bromine, the carbon attached is labeled as carbon 1. And for this structure, we have nitro and also chloro. Okay, so which of the carbon is labeled as carbon 1? So based on alphabetical order, C comes first. So Cl, the carbon attached to Cl is labeled as carbon 1. So we have 1, 2, 3. Okay, so the position is 1 and 3. So we can use M-chloro-nitrobenzene, or if we use numbering, it will be 1-chloro-3-nitrobenzene. Okay, so let's look at more examples. So you have your NH2 and then CH2, CH3. Okay, so there's one rule. Okay, so if the substituents, okay, is from the functional group, okay, so there's one rule, okay, which we need to apply based on the priority of the common substituent. So these are the when there are different functional groups, okay, attached to the benzene as the substituent. So the priority, okay, will increase from alkanes to carboxylic acid. So means that when I have alkane group and also my amine group, okay, so the priority will be given to amine functional group. So amine functional group will be the carbon with the amine functional group will be labeled as carbon 1. So here, the carbon attached to NH2 is labeled carbon 1. So 1, 2, 3, 4. So as you know, the NH2 with the benzene ring, we have also the common name. So NH2 with benzene ring, the common name will be named as, so we see this as a compound which is known as aniline. So the parent, okay, is called aniline. So the IUPAC name will be 4 p-ethylaniline or p-ethylaniline. So P is telling us the ethyl is at the position number 4. So it's 1 and 4. So I think it will be easier for you if you use the number to give the IUPAC name instead of the prefixes. Okay, so remember when we want to select one of the substituents that give the new parent name and number as carbon 1, okay, it will be based on the priority, okay, it will be based on the priority of the main, okay, of the functional group. So now carboxyl group and the nitro, which one should be your priority? Okay, so it will be your carboxyl group. So the carbon attached with carboxyl group will be given as carbon 1. And we also have the common name when the carboxyl group is attached to the benzene, which is known as benzoic acid. Okay, it's known as benzoic acid. So the benzoic acid will be our parent name, and the nitro is attached to carbon 4, so it will be 4-nitrobenzoic acid, or also known as position 1 and 4 is P, okay, para, so it will be p-nitrobenzoic acid. Okay, so here we also have two functional groups, which is OH and CH3. Okay, so based on the priority table just now, okay, so alkene is at the lowest priority. Okay, so phenol has higher priority than our alkyl group. Okay, so the parent here, okay, the carbon which attached to the OH will be number as carbon 1 because the hydroxyl group has higher priority. And at the same time, the hydroxyl group attached to a benzene, okay, we have the common name which is known as phenol. So the parent name is phenol, and we have the CH3 which is attached to a carbon number 3. So it will be 3-methylphenol, or we can use a prefixes which is position 1 and 3 will be M-methylphenol. Okay, so let's look at more examples. So CHO and Br. So the CHO is the aldehyde, okay, which have the carbonyl functional group. So carbonyl functional group has a higher priority than the bromine. So the carbon is labeled as carbon 1. Okay, so this one will be carbon 4. So here we can have the parent, okay, the common name for the aldehyde attached to the benzene ring is called benzaldehyde. So it will be 4-bromobenzaldehyde or p-bromobenzaldehyde. So for trisubstituted benzene, we need to assign the lowest set of number to all the substituents. So for example, here I have 3 bromo substituents. Okay, so I have to find a way where it can give the all the substituents the lower number. So there are a lot of possible ways. So let's say if I start the numbering, okay, from the bottom, okay, so it will give the Br, okay, at the bottom, carbon 1, and then carbon 2, and carbon 4. So this one, I will get a set of 1, 2, 4. And then the other one, if I start from the top, it will give the substituent the set of 1, 3, 4. So actually there are a lot of possible ways of giving the numbering to your carbon in the benzene ring. Okay, so based on this one, 1, 2, 4 is lower set than 1, 3, 4. So the correct IUPAC name for this structure should be 1,2,4 tribromobenzene. So when the trisubstituted benzene, okay, when all the substituents are different, we always have to go back to the priority table where the higher level groups, okay, will be labeled as carbon 1. So here we have your hydroxyl group, okay, which is at the higher level. So the carbon attached to the hydroxyl group will be labeled as carbon 1. So when the hydroxyl group is labeled as carbon 1, this actually gives us the common name of the benzene, which is known as phenol. So the parent is known as phenol, and we have the substituent at carbon 2 and 4, which gives us the IUPAC name of 2-nitrophenol. Okay, so next, okay, for this example, we are going to give the numbering to all the substituents so it can have the lowest set of number. So from here, okay, the best way of numbering is start from the Cl, okay, and then we have the NO2 and NO2 attached to the second carbon and the bromine attached to the fourth carbon. So after that, when we want to combine them into a single IUPAC name, okay, so we have to follow the alphabetical order. So my substituent is 1-chloro, 2-nitro, and 4-bromo. So to write the IUPAC name, we follow the alphabetical order, which is B come first, and then followed by C, followed by N. So it will be 4-bromo, 1-chloro, 2-nitro, benzene. Okay, so next example, we have COH and NO2. So based on the table, carboxyl group has a higher priority. So the carbon attached with carboxyl group will be labeled as carbon 1. And we have a common name when the carboxyl group attached to benzene ring. The common name is benzoic acid. So the IUPAC name will be 3,5-dinitro-benzoic acid. And then based on this structure, okay, so alkyl and halides they are on the same level in the priority table. But remember, when the methyl group is attached to the benzene ring, we also can have a common name. So the CH3, okay, attached to the carbon is known as carbon 1. So this gives us a new parent as toluene. So my Cl will be attached to carbon 2, 3, 2 and 4. So it will be 2,4-dichlorotoluene. Okay, so next one, phenyl group. So our benzene ring will be known as phenyl group, okay, when they appear as a substituent. Okay, so here my benzene ring is a substituent. So when it appears as phenyl group, okay, the formula will be C6H5. So what is the condition when my benzene ring become a substituent? So if the alkyl group, okay, attached to the benzene ring is more than 6 carbon, so the compound, okay, the parent will be given to the alkyl group, and my benzene ring is going to be a substituent. So look at this example. I have a straight chain and my benzene ring. So this straight chain is made of 1, 2, 3, 4, 5, 6, 7 carbon. So 7 carbon is more, okay, 7 carbon straight chain has more carbon than the benzene ring. So here my benzene ring is going to be the substituent. So the parent will be given to the straight chain carbon. So the parent is known as heptane, and my benzene ring is attached to the second carbon of the straight chain. So it will be 2-phenyl-heptane. And also if the chain is unsaturated or the chain contain other important functional group, so our benzene ring will also appear as a substituent. So it will be known as phenyl. So for example, I have the alkyl group, which consists of a carbon-carbon triple bond. So the carbon-carbon triple bond, so the chain contain carbon-carbon triple bond will be my parent. So benzene here will be substituent. So the IUPAC name, it will be 1-phenyl 2-butane. So 1-phenyl tells us the position of the benzene ring, which is attached to the first carbon of the parent, and 2-butane. So the 2 tells us the carbon-carbon triple bond, is at the second carbon. So the next one, so alcohol, so when you have your alkyl group, with the hydroxyl functional group, so the parent, will belong to the straight chain with the hydroxyl functional group. So this one, the parent is known as ethanol. So the carbon with the hydroxyl group will be numbered as carbon 1. So the benzene ring is attached to carbon 2. So the IUPAC name will be 2-phenyl ethanol. So for benzyl group, so this is the structure of the benzyl group, where the benzene ring with the alkyl group of CH2. So normally the benzyl group is attached to a functional group. So for example, the benzene ring of CH2 and Cl. So this halogen functional group is chlorine. So it will be, the IUPAC name will be benzyl chloride. So you can see a benzene with a CH2. So this is our benzyl group and is attached to a hydroxyl group. So hydroxyl, is alcohol. So we call it benzyl alcohol. And NH2, our functional group is amine. So it will be benzyl amine. That's all for today for our session. So at the end of this lesson, you should be able to give the IUPAC nomenclature for the benzene derivative. So if you have any questions, please feel free to leave a comment. Thank you.